During the last years, Germany had to face several large wildfires. Especially the northeastern part of Germany, with sandy soils and wide areas of monocultures, had been prone to forest fires that posed significant challenges for fire brigades. Within the German pilot of the TREEADS project, the Otto von Guericke University Magdeburg and the Federal Institute of Materials Research and Testing are working together to investigate fire and smoke spread mechanisms of national vegetations. Our fire research institutes are located near areas that have been affected by forest fires in recent years. We are conducting experimental and numerical studies on ignition mechanisms, fire behavior, and fire spread.
Our experimental studies are investigated at different scales in order to understand both basic chemical mechanisms and physical propagation processes. While in the laboratory the focus is on the fundamental fire characteristics and their reaction mechanisms, the spreading phenomena with complex interactions are investigated in large-scale fire experiments. The experimental studies are used for validating numerical simulations. By simulating the spread of fire and smoke, scenario-based assessments can be made. Our data contribute to national and international fire safety research and can be used in further fire spread models. Smoke from wildfires impairs visibility during a fire and contains numerous toxic and irritating substances. Depending on the concentration and duration of exposure, inhaling fire smoke can lead to long-term damage or death within minutes. Within our pilot, we've been to determine 6 key components of smoke that is emitted during national wildfires. We have been able to determine that the emitted smoke contains concentrations of toxic levels and that our firefighters must be protected from the hazards by personal protective equipment.
In Germany, we are experiencing hotter summers with a lack of sufficient rain. The higher temperatures are leading to a dry out of the vegetation and a higher risk of ignition. We are working on the response side of a forest fire. By characterizing combustion phenomena of national wildfires, we provide a contribution in prediction of fire and smoke production as basis for effective firefighting measures and health risk assessments. Within our fire tests, we are also able to test different extinguishing agents.
The eco-friendly extinguishing foam ensures much better moisture penetration into the soil. This means that even deep-lying pockets of embers can be successfully extinguished and the cooling of the burning material lasts much longer. This is an immense advantage, especially in the view of difficult water supply. Our studies conducted within the project have also shown that the foam has no damaging properties on plant growth when used in vegetation fires.
The project findings help us to do for first time the assessment of field risk for our firefighters and people affected by wildland fires due to the determined composition of the smoke gases. On the other hand, we are also able to fight more effective against wildland fires by the investigated horizontal and vertical fire spread and the smoldering in-ground fires. All in all, we develop new skills and abilities to fight more effective against wildland fires by the analyzed fundamental problems in forest firefighting and the collected wide range of data which was previously not available for the fire science community.